Okay, so let's go ahead and begin routing some exposed conduit in our control room here. I want to hide these tags, so I'm going to select one and then go to the temporary hide isolate, and I'm going to hide that category. So these are temporarily hidden within this view alone. Once I close the view and reopen it, they will reappear. Um, Before we get into conduit, just real briefly, I'm going to assume that you have some experience using conduit already. If not, please complete the tutorials that are mentioned in the preliminaries document that goes along with this video series. But just real briefly, there are two main types of conduit that are in use within Revit: the conduit with fittings and the conduit without fittings. Conduit without fittings doesn't draw individual conduit fittings. It just draws a straight run of conduit. Conduit with fittings will give you a demarcation at every elbow or offset. As you can see here, all the conduit that we've set out to use is based on the conduit with fittings. That gives you a clear indication of where the fittings are, and the run helps with modeling, in my opinion. If you prefer using the conduit with fittings, be my guest. The one thing to be aware of, however, is that in our standards document, our WETS CAD BIM management plan, section 512 conduits, it states that each unique set of conduit material and fitting shall be assigned a conduit type. Each conduit type shall have the following naming convention, and then that is material followed by all the fitting types. So that would actually be the name of the conduit run. That means in practice is that when you want to use a specific fitting, you don't just place the fitting, you create a type that includes that fitting. So if you want to use elbows, you create a type that uses elbows. If you want something that uses LBs, you need a type that uses LBs for your bends. Let's go ahead and we'll start here with a galvanized rigid because we're above ground. And we're going to start routing conduit from these FD boxes into this pull box over here. We're going to use elbows, and then we're going to throw in a couple of LBs and T's in there just to show you how things work. The best way to go about routing conduit is to start from your most constrained position. If you hit WT and tile your windows here, go to the plan view, you can see, close that one, you can see that these boxes, the fitting location is very close to the wall, whereas with this box, you stick out 8 inches. So if you tried to start from here and went to this box, you would have to transition, and it would be very hard to hit that conduit connection right on. So it's easier to start from this tight conduit connection and come over to this box. So that's what we're going to do. Just draw a conduit. Make sure that we have selected the conduit with fittings, the GRC with an elbow. And just ties right over. And if you want to get very detail oriented, there is a standards document in our Revit standards folder, or rather no, it's in the electrical standards folder. Under industry standards, the NEMA document on good workmanship in electrical construction. And my Adobe Acrobat is doing something here. If you go to page 11, it shows minimum raceway spacings between different conduit of the equivalent sizes. So if you're doing a layout of a lot of conduits along one box, this will give you an indication of where you want to space everything, and it will match what the contractor's going to do. So if we are using 3/4 inch conduit, the average diameter, or approximate diameter, for a 3/4 inch conduit is almost 1.5 inches. So let's maintain a minimum space from the wall of 1 inch off the side of the edge of the box for that conduit, and we'll make our connection. And there it is. It's made a quick connection. Why don't we spread these out, and we will model a T-fitting. We'll go from this conduit here, and we'll T over into this one, and you can see it immediately makes a T-fitting. And you can see one of the things that you want to take into consideration when you're routing conduit is that you want to think like the installer. So this is the closest box, or this is the closest FD box to this box, so we started in on the bottom, because as progressively as you come in, you're going to have to stack conduits on top of this run. If we had tried to come from this section, or rather from this FD box into this top section here, and then we tried to route a conduit through this way, we'd end up with a collision. Just to illustrate that, it might be better to demonstrate. So let's assume we tried to make our first connection up here, and I didn't connect that, I just want to show what will happen. Now if I want to come in, and I don't want to T through, I want to connect through this box, well now I have real trouble. These are conflicting. So it illustrates that when you are modeling conduit, this is not like AutoCAD where you can just place some lines and leave it up to someone else to figure out. It's really becomes incumbent upon the designer to have an idea of how the conduit is going to be installed. And I think this one may be a little tweaked from getting moved around, so delete it and start over. This one, again, we're connecting to the bottom section of this box, and we'll just finish the connection there. Let's say, for the sake of argument, that we want to have we want to have the initial run come off of be evenly spaced around this conduit. Let's just demonstrate how to use the parallel conduits tool. So you select a conduit, and then this will create a series of parallel conduits along this same route. You specify the offset here. We said it was, if we look at our workmanship manual, if we have 3/4 inch conduits, the minimum spacing between them should be 1 3/4 inches. So set this offset to 1.75 inches, and we want 3 of them because we have 3 FD boxes. Now you've got 3 conduits all connected to this box that are at the minimum required spacing. If you want to connect 2 corners of existing conduits, or you want to connect 2 existing conduits at the corner, you can use the trim extend to corner, select the 2 conduits, and it will create whatever bend you have specified. Let's we'll do one more. You can also push TR to get that same effect, but you do have to have a conduit at the other end, so we'll start drawing a conduit here. So now we've created 3 conduits. Let's go ahead and we'll demonstrate how to create a conduit type that uses LBs, because we'll say we want an LB coming out of this box and coming down into this wireway. So go ahead to Systems, Conduit, to begin placing the conduit, and in the Properties window, we notice we don't have any GRC with LBs. We've got a PVC 80, So what we'll do here then is edit the type, and this gives the selection of conduit that we're going to be, or the selection of fittings that we're going to be using for this conduit type. So because we're going to be using a type with an LB for the bend, we will create a new type. Instead of an elbow for the bend, we'll be using an LB. The standard is going to be still the GRC sizing standard. The bend type, now we're going to select an LB. So we have conduit body type L, GRC, so that's the one we want. While we're here, let's take a note of a couple of the critical descriptive parameters. When you start doing the scheduling, the most important parameters are the type comments. This is the material type that will show up in the conduit schedule. Description is if you put the conduits on the equipment schedule, this is the description line that will show up on the description line. Part number also will show up on the equipment schedule if you choose to have this conduit type show up on the equipment schedule. And then these are the various fittings that you're using for this conduit type. And so now we see that we have an LB selected, so let's start here on this box. We can just finish that connection there, and we'll draw it out and bring it down, and notice it's got a cannot connect or cannot draw symbol because it says that we don't have enough room. So if we try to bring it out and then down, then it gives us the LB. But notice how it gave us this LB, this horizontal LB. That's probably not the one we want. We want a vertically oriented LB. So in order to get that to happen, what you need to do to get the vertical oriented LB, you need to start on a vertical run and finish on a horizontal connection with another box. That's probably easier to demonstrate than to talk about. So let's move this over just a little bit so we have room to make our conduit connection. So to get that vertically oriented LB, you first have to start on the vertical run and then transition into a horizontal run, and let's see, let's make sure that it actually gives us that connection. No. That's the other thing you have to do, is you have to make sure that you finish your connection on another box, another piece of equipment. And sometimes even then it doesn't want to do it for you. Whoops. Let's try that again. Okay, there we go. So, just to reiterate, if you start on a vertical run, finish with a connection to a box, it will give you the connection. If you notice when we tried to, if we disconnect this one, and then we try to reconnect it, it's going to redraw this conduit with the it's going to redraw it from this direction into this direction, and that starts on a horizontal run, so you'll get a horizontally oriented fitting. Or not. Sometimes it does, sometimes it doesn't. If, however, we tried to draw in this direction. Yeah, see, now it gave us the horizontally oriented fitting because it started with a horizontal run. So working with LBs can be very difficult within Revit. It takes a little bit of practice sometimes just to get what you're actually after. Alright, so now we've got some overhead conduits. Let's go ahead and we will number these. It's important to make sure that we number all of our conduits so that they show up in the schedule correctly. There are a number of parameters that show up on the conduit schedule, but the most important one for the initial modeling phase is just to set the conduit number. These could be alphanumeric, they could be straight numeric. It's really up to your preference. These are all power conduits, so we'll start with P100. And the conduit schedule schedules only the straight pieces of conduit. It's really unnecessary to go ahead and schedule the fittings. In fact, as we've seen here, Revit will redraw your fittings if you break the conduit at some point. So numbering and putting information in for the fittings can be a waste of time if you end up having to do any conduit rework. P102, and we'll call this one P103. Just for the heck of it, we'll call it C100. It's not how you would do a real model, but it's good for this example because of how we're going to schedule the conduit later. So that concludes our overhead conduit. The next thing we'll do is go into doing underground conduit with sweeps.